Okay, and then for this function, this graph, we want to do the same thing. You'll want to factor just to make sure that nothing cancels out. The denominator, can we factor? 2 times -3 makes -6. So I need two numbers to multiply to be -6, but have to be -5. So how about minus 6x plus 1x? Okay, and then we can factor by grouping. I can tell this isn't going to be a problem. We're okay. So we can just leave it down here the way it is. Actually, let's factor because then it'll help us solve. So we get x minus 3, and then this is 1x minus 3. Okay, so I just took the bottom, and I'm factoring it by grouping. So I can take out an x minus 3 from both of those terms, and I'm left with 2x plus 1. So I just rearranged the bottom, and I was doing it really to make sure I didn't lose anything up here. If they cross cancel, then you don't have a vertical asymptote, but they don't cross cancel. Okay, so there's actually going to be two vertical asymptotes at x equals 3 and at x equals -1/2. And I get that because if you plug in -1/2 in here, 2 times -1/2 is -1, -1 plus 1 is 0, and that would cause a divide by 0 error, right? So those are our two vertical asymptotes. So to check the behavior, you could use a graph, or you could do what I did up above, where you just check some numbers that are really close. So I'll make a quick table. I'll check what's going on to the left of x equals -1/2 first, I guess. So I'll do -0.501. I'll plug that in and see what we get. 0.501 negative. Let me square that times 2, and then 0.501 times 5. That's a negative times a negative, so that makes a positive. So the denominator, get this. In the numerator, if I do 1 minus a negative 0.501, that's the same thing as adding 0.501. So I get -6.15. And then if I plug in something even closer, probably best, this takes a while. If you're allowed a graphing calculator in these types of questions, definitely use it because it's time consuming to plug in these numbers, huh? So something even closer. I took -0.5001, and I'm going to square that times 2 because I'm figuring out the denominator first. And so 5 times, oh shoot, I forgot what it was. I squared it times 2. Okay, so now I got 0.5001 negative times a -5 plus my previous answer, subtract 3. So that's my denominator. And my numerator is 1.0511. So we divide those. Oh, I get something positive. Maybe I messed up the first one. Okay, let's just graph it. But you get the idea. You plug in those numbers. 1 minus x. Plug in those numbers to see, like this one, it was trending towards positive infinity or negative infinity. 2x squared minus 5x minus 3. So there's our vertical asymptote at x equals -1/2. So I messed up when I plugged in -0.501 because it goes to positive infinity from the left. So for this one, the left, I'll just use L for left, positive infinity, and then from the right on this asymptote, we saw the graph showed us negative infinity. And then same thing for this one, it's positive infinity and negative infinity. So positive infinity from the left, negative infinity from the right. So it's actually the same for both. Okay, and then one more, secant of x. The limit as x approaches positive infinity and negative infinity. So think about, I guess if you haven't studied the graph of secant of x, you want to just take a quick look. Makes these U shapes, okay? And it keeps fluctuating because it's a sinusoidal, it's based off a sinusoidal function, so it keeps repeating over time. As x goes to infinity, we just keep repeating that pattern of u's and n's, u's and n's. So as x goes to infinity, we don't get any closer to a value. So it's undefined. Oh, but it's saying at the vertical asymptote. Sorry, I've been doing this question too long, I guess. I was thinking the limit as x goes to infinity of this whole thing. But they want vertical asymptotes. And so this is what we should do. Secant is the reciprocal of cosine, right? So a vertical asymptote is where you have a divide by zero error. So that's why on the actual graph of secant of x, that's why you'll see vertical asymptotes in between these, because one divided by cosine, you can have plenty of an infinite amount of vertical asymptotes. So what values makes cosine equal 0? Cosine is the x-coordinates on the unit circle. So here on the unit circle, we're at 1, 0. This is 0, 1 because we're at 1 on the y-axis. Negative 1, 0, 0, negative 1, right? So cosine is 0 here and here. And then every 2 pi, we get another 0. So at pi over 2, you have a vertical asymptote. Okay? Pi over 2, and then we usually say plus 2 pi k. You don't have to do this part, but this says if k is an integer, this represents the infinite amount of different asymptotes. But pi over 2 is an asymptote, and then negative 3 pi over 2, which means 270 degrees is our other one. Okay, but the big thing is recognizing that these reciprocal functions can be rewritten like this so you can find the vertical asymptotes.